In this video, we're going to have a look at how electrical transformers work. We'll look at the basic underlying theory of how they work. I'll explain to you why we need transformers. We'll look at some of their typical applications. And then we'll look at a real world example of a transformer and look at some of its main parts. Now you might be wondering, why do we need electrical transformers in the first place? You'll see step-up transformers outside power stations, and you'll see step-down transformers in open-air switchyards and substations. Well, the important thing to realise here is that irrespective of if we're using a step-up or a step-down transformer, the electrical power output of that transformer remains fairly constant. I say fairly constant because there are some losses, but let's just assume for the moment that the amount of power that we put into the transformer is the amount of power that we get out of the transformer. With this setup, we've got something that they refer to as a step-up transformer. That is a transformer that increases voltage. The opposite of a step-up transformer is a step-down transformer because it decreases voltage. What's really fascinating is that when we change from positive voltage to negative voltage, the direction of current flow reverses. Because the direction of current flow reverses, the direction of the magnetic field around our conductor also reverses. When current flows through a conductor, it creates a magnetic field around that conductor. If current flow is in only one direction, we refer to it as direct current. When current flows in only one direction, the direction of the magnetic field that is created around that conductor also only has one direction. When it gets interesting though is when you take the magnet and move it around a bit. By moving the magnet from left to right, we can actually induce a voltage in our conductor, and because our electrical circuit is closed, we get current flow.